Let's talk about some special right triangles. Let's first talk about the 45, 45, 90. So the 45, 45, 90, what this represents the angles of the triangle. So we have a 45, 45, and then a right angle, or 90 degree. Now because this triangle has two congruent angles, we know that this is an isosceles triangle. And in an isosceles triangle, the sides opposite those angles are going to be congruent. So this side is going to be congruent to this side. Let's call these sides x. Now, in a right triangle, we know this formula. So a squared plus b squared equals c squared. So if you have like a random right triangle, this side squared plus the other side squared equals to the hypotenuse squared, okay? So the sides that are not the hypotenuse squared added together equals to the hypotenuse squared. And let's apply this formula to this right triangle. So this side squared, right, x squared, plus the other side squared, which is also x squared because it's isosceles, equals to this unknown side. We're trying to find the hypotenuse. Let's call it c. So this is going to equal to c squared. Simplifying this, we get 2x squared equals c squared, right? Because you're just combining this together. Take the square root of both sides. This cancels out to be c. And you're going to get c equals radical 2x squared simplifies to radical 2 times radical x squared. And radical x squared is just going to be x. So it's just going to be radical 2 times x, or x radical 2. So c equals x radical 2. And in case you're wondering about this step, if you have something like 2 raised to the second power, the square root and the exponent is just going to cancel out, right? Because square root of 2 squared, that's just going to equal 4, and then it's just going to simplify back to 2. So anything raised to the power of 2 is going to be just itself without the square root. Okay, so c equals x radical 2. And it turns out that for any 45, 45, 90 right triangle, so any right triangle that has these degrees, it turns out the hypotenuse of this triangle is always going to be radical 2 times longer than the shorter sides. So let's say if we have a right triangle, and let's say that doesn't look like one. Let's say we have a right triangle, and let's say that we once again have our 45, 45 right triangle. Let's say this side was 6. What do you think the other sides will be? Well, from this diagram, obviously, the two shorter sides are going to be the same length because they're isosceles triangle, same sides. I mean, the sides opposite to the angles have the same length. And then the hypotenuse, well, instead of trying to do the Pythagorean theorem all again and solving for the hypotenuse, from this theorem we just did, and from this proof we just did of the 45, 45, 90 right triangle, we can now just say that this hypotenuse is 6 radical 2. The hypotenuse of any 45, 45, 90 triangle is radical 2 times longer than any of its shorter sides. Let's say that we have an equilateral triangle. All these sides are congruent. So let's actually call all these sides 2x. And then all the angles are congruent, obviously. All of them are 60 degrees. Now let's draw altitude of an equilateral triangle for this equilateral triangle. An altitude is just a line that goes from one vertex of this triangle to the opposite side, and it creates right angles, okay? So it's just line from one side, one kind of vertex, goes to the other opposite side, creates right angles. In an equilateral triangle, if you, I'll just write this down real quick. Okay, so handwriting might be a little bit sloppy, but just says that if you draw an altitude for an equilateral triangle, the altitude is also an angle bisector, so it splits this big angle into two equal parts, so two equal parts, and a median. So it splits this segment into two equal parts, which means this part is x and this part is also x. And if you're wondering like where I got this theorem from, well, we know that these two angles are 60 degrees, right? Because it's an equilateral triangle. This whole thing's an equilateral triangle. And we have an angle, we have a side, we have an angle. So now, based on ASA, we can say that these two triangles are congruent. And corresponding parts of congruent triangles tells us that these two sides have to be congruent, so it's a segment bisector or a median, and it's an angle bisector because it splits this angle into two equal parts. Now, we have our hypotenuse length. This is 2x. We have one of the sides. But let's solve for the other side using Pythagorean theorem. A squared plus b squared equals c squared. This time we're given the c squared. So we're given the c value. And we're given another side. And let's solve for this final side. Let's say this side is y, okay? So y squared. Well, this, you can think about it as distributing the exponent to the 2 and the x. So it's just going to be 4x squared equals x squared plus y squared. And, you know, if you subtract x squared from both sides, you get 3x squared equals y squared. And then if you take the square root of both sides, you're going to get y equals square root of 3x squared. And this is just going to be radical 3 times x squared, which is just going to be equal to x radical 3. So y equals to x radical 3. So from this proof, we just concluded that in a right triangle, where you have a 90-degree angle, 30-degree angle, 60-degree angle, the hypotenuse is 2. Let's just say, actually no, let's just say the side opposite to 30. The side opposite to 30, let's say it's x, it's not a random value. Well, the hypotenuse is always going to be 2 times that value, or 2x. And the side opposite 60 is always going to be that same side times radical 3. Right triangle here, 30, 60, right? Let's just say this side is 6. Well, if 6 is our x value, then our 2x value is going to be 2 times 6, which is 12. So the hypotenuse is always going to be 2 times longer than the side opposite 30. And the side opposite 60, well, we know the side opposite 60 is radical 3 times longer. So if we want to get x to x radical 3, just multiply 6 by radical 3, and you're going to get 6 radical 3. Let's do another example. Let's try to do it without the thing this time. And this one's going to be a little bit tricky. Switching up the angles right here. Okay? Let's say that we have this side, 7 radical 3. Solve for the hypotenuse, solve for this side, and solve for the other side. Well, we know that this side is opposite 60, which means this side is our x radical 3 value. So to get to the x value, right, we just have to divide everything by radical 3. And that's what we're going to do. 7 radical 3 divided by radical 3, x is equal to 7. So this side's equal to 7, right? Because the side opposite 30 is always radical 3 times less than the side opposite 60. And we know the hypotenuse, well, it's going to be 2x, 2 times the length of the side opposite 30, right? So that's just going to be 7 times 2, which is 14. Well, I've drawn 4 right triangles. And using what we just learned, try to solve for the missing sides. So, for example, in the first triangle, solve for these missing sides. Solve for these missing sides, etc. In the first triangle, we can see that this is a 45, 45, 90 right triangle, which means it follows this theorem. So it kind of follows this. So you have 45, 45, right? And remember what we did? These sides are equal because it's an isosceles triangle, and the hypotenuse is always going to be radical 2 times longer than the sides. If we're given the hypotenuse, then if we want to go back to one of the sides, we have to divide this by radical 2, right? Because then the radical 2's would cancel out, and we would just get x. So 9 radical 2 is our x radical 2 in this case. If we want to go back to this, if we want to go from x radical 2 back to x, in this case, we want to go back from 9 radical 2, well, we just divide the side by radical 2, and we get 9. Which means that the other side also has to be 9, because isosceles triangle. This one. Well, 30, 60, 90, remember? We just did this. The side opposite 30, that's your x value. Let's just say it's x. Side opposite 60, always radical 3 times longer than x. And this is the hypotenuse, the side opposite the 90-degree angle, that's going to be 2x. So that's going to be 2 times the side opposite to the 30-degree angle. So if we have the hypotenuse, which is 2x, so 2x equals 8. Well, if we want to solve for x is just going to be equal to 4, right? X equals 4, which means the side opposite 30 equals 4. And this means that the side opposite 60 is x radical 3. So 4 radical 3, right? 4 times radical 3. This one. Remember 30, 60, and 90? Side opposite 60 is your x radical 2 value. X radical 3 value. So to get from x radical 3 back to our x value, aka the side opposite to the 30-degree angle, we have to divide this by radical 3. So 5 divided by radical 3, rationalize the denominator. You're going to get 5 radical 3 over 3, and let's leave it as that for now. And if your x value is this, we know that the hypotenuse is 2 times longer than this x value. It's 2x. So this is just going to be equal to 10 radical 3 over 3. We just doubled this amount. Finally, we have this. This one, for some reason, I didn't mark angles on it. Really weird. Okay. So let's just... Okay. We know that this hypotenuse is 2x, right? Because it's for 30, 60, 90 right triangle. Which means x, aka the side opposite 30, that's just going to be equal to 2. Which means the side opposite 60, that's just going to be equal to 2 radical 3, right? X radical 3, and 2x. Let's try to make this a little bit trickier. Say we have a 45, 45, 90 triangle. But this time, our x radical 2 value is simply an integer. How would you solve for x? So the other two sides. The hypotenuse is x radical 2. So to get from x radical 2 back to x, we have to divide by 2, right? So if we want to get back to x, it's just going to be 9 divided by radical 2. And rationalizing the denominator, because we don't want radicals in our denominators. That's kind of unclear. So you just multiply by the denominator itself in this case, and on the top and the bottom, and you would get 2 over 9 radical 2. And x would just equal this. Okay? So it doesn't matter if, your hypotenuse is an integer. Your hypotenuse doesn't have to come in the form of something like this, right? Your x radical 2 can simply just be an integer. And to solve for that, you would just have to divide by radical 2 to get to x, okay? So whenever you're doing these types of questions, you should be thinking, oh, what do I have to multiply, or what do I have to divide by to get from x to x radical 3, to get from x to 2x, whatever, okay? And say we have another right triangle. So we have this one. Let's say this side is 30, and let's say this side is 60. Let's say that let's say the hypotenuse is 5 radical 2. What's the other sides? The hypotenuse, we know the hypotenuse is 2x, right? And the side opposite 30 is x, which means to get from 2x back to x, you would just have to divide things by 2. So x is just going to be equal to 5 radical 2 divided by 2. And to get from x to the side opposite 60, aka x radical 3, well, just multiply everything by radical 3, and you would get 5 radical 6 over 2. That's your answer.